for this particular system, we're going to work out the magnitude and the direction as we've done for some previous videos. This problem is not different from any other of the problems that we've solved. The only difference is that there's a downward force here of 65 kilonewtons, newtons, whereas the same principles still apply. The first step would be to start by splitting these forces into their x and y components. So we know the sum of the forces in the x direction equals, so 40 cos 22, that would be the first part of breaking that force down into its individual components. So then minus 20, which is the horizontal force, and then minus 100 cos 48. So once you've put that into your calculator, you will end up with an answer of minus 49.82 kilonewtons. Just a reminder that for this particular problem, I've kept the units the same throughout. In this case, we are using kilonewtons. However, you should also note that for some more difficult problems further on, then I may change the units and do the necessary conversions, and that may be something you may need to brush up upon as we go through this lot of videos. So we can then apply the same principle and work out the sum of the forces in the y direction. So the sum of the forces in the y direction equals 56. So if we do 56, no, if we do 100, sorry, sine 48, so break that down. And then we can do plus 40 sine 22. Then we minus the downward force of 65. Then once you put that into your calculator, you should then get an answer of 24.3 kilonewton. I do appreciate that breaking down the forces into their x and y component can be difficult. To make that process easy for you and to ensure that you understand what you're doing, I often make annotations on the actual system, which will assist me when I need to resolve a force. So the next step would be to work out the resultant force. As explained in the previous video, the resultant force can simply be calculated by doing fx squared plus fy squared. So in our particular case, we would then do R equals the sum of the force, which we've got on a minus 49.82 squared plus f of y, which in our case would be 24.3 squared, and then that would then give you a resultant force of 55.43 kilonewtons. So that's great. Just a reminder, when popping this into a calculator, do remember to include the brackets, otherwise you may get an invalid answer depending on the calculator model that you're using. So we then can also work out the direction, and in order to do that, there is a formula. So theta equals the inverse of tan, so tan minus 1, and then it's the sum of the forces in the y direction divided by the sum of the forces in the x direction. So next, we just pop in the numbers that we've calculated for the x and y components into this formula. So theta equals tan minus 1. Sum of the forces in the y direction we got as 24.3. Sum of forces in the x direction we got as 49.82. And you would, once putting that into the calculator, you would then get an answer of, it'll be around 0.88 degrees. No, no, it wouldn't. It would be 26 degrees. So that's, I do hope that you've enjoyed this video. This is going to be part of a series of videos where we firstly start off with the basic mechanics, and then we gradually transition into more difficult systems. We could be working on moments, beams, and more technical applications. I do hope that you've enjoyed this video. Do please take the time to like, share, and subscribe, and see you for the next one.